The last very important concept of operating system is operating system structure. The general purpose operating system is very large and complicated. So we need to define a structure for it, which can help us better understand and well organize it. So basically, there are several ways to structure the operating system, and those structures evolved from time to time. And here list a numbers of different ways. And the most simplest way is a simple structure. Later, people found that the simple structure is not good enough. Then we have beyond simple but not layered. And we also have examples for each one of them, MS-DOS and the original Unix. And these two are also referred to as a monolithic structure because there's no layered concept there. Everything united inside a big chunk. So that is why we call it a monolithic. Later, the developers and the researchers of operating system, they provide more advanced structures to better organize the operating system so that it can be easier developed and managed. For example, layered approach, microkernel structure, module structure, and also nowadays, most of the operating systems, they combine different basic structures together to better fulfill the design goals there. And in later slides, we are going to talk about those structures one by one. First, let's see the most simplest one, the simple structure with example MS-DOS. So at the early stage, due to the very limited memory and the storage size, the optimized design goal is to squeeze the size of the operating system, and at the same time to add more functionalities as we can. And also, we need to reserve enough memory space and the storage space for user programs or application programs. So from this figure, you can see that they put all the critical part within a big chunk. Actually, this part. Within this big chunk, there are different device drivers, different functionalities, and system services. And the whole structure is quite simple. So there's no well-defined interfaces. There's no defined separated functionalities. The mainly reason is because the very small size of memory space and the storage space. Later, the operating system became very complicated because we need to add more functionalities there to better serve the user. So at the same time, and the operating system started to be shared by multiple users and running on a server. As we already mentioned that a mechanism needed to be designed is to make the operating system protect itself and protect the normal users from the misbehavior users. Then from this figure, we can see that there is a clear separation between kernel and the user space. So this is the unique feature, which is different from the simple structure. And also, why we call it beyond simple but not a layered structure is because inside the kernel, we have a more clearly defined functionalities. For example, we have signaling, different device drivers, file system management, I/O control, and CPU scheduling, etc. So we have a lot of features clearly defined inside the kernel of operating system. However, and those functionalities are still interleaved together without well-defined interfaces. So they are still not layered. It is still a big chunk. So that is why we call the simple structure and beyond simple but not layered structure as monolithic structures. Later, the operating system became even more complicated. The developers of operating system think about that. So how can we well define each functionality and make those functionalities fully separated, well maintained, and with well defined interfaces? So later, when we want to change one layer or change one functionalities, as long as we follow the definition of a layer interface, it won't affect other layers, so which can make the operating system very easy to maintain. So ideally, the layered structure are maintained like this. So in the center of the structure is a layer 0, which is the hardware. On the most outside of the structure is layer N, or we call it user interface. The layers in between are system functionalities, with each functionality defined within a separated layer. So with this layered structure, each functionality can well maintain an interface to its neighbors and also provide service to the upper layer. So for example, layer 1 will maintain an interface between layer 0 and layer 1, and also request the service from layer 0. And layer 2 will request the service from layer 1, so on and so forth. For doing that, the operating system can be easily maintained and structured. So when you want to apply new functionalities into the structure, it is very easy to do so. Unfortunately, this is just the ideal case. So besides the hardware layer and the user interface layer are pretty clear, other layers actually are very difficult to be identified and well defined. So I can give you an example. There are three major functionalities in the operating system, which are CPU scheduling, and also memory management. And the last one is storage management. Since they are major functionalities in the operating system, so they should be defined in three layers in this approach. Then the only task you need to do is to define the orders. So which one should be the layer 1, which one should be in layer 2, and which one should be in layer 3. Then let's look at the main memory. So since nowadays the size of most applications is bigger than the size of main memory, therefore only part of the application can be loaded on the main memory. Other part of the application needs to be stored in the storage, such as the hard disk. The main memory needs to need the service provided by the storage management layer, right? And also, the layer rank of memory management should be higher than the storage management layer. Then let's see, for storage management, the operations of storage management rely on the device driver, and the device driver must be loaded into the CPU to process the operations when the CPU is available based on the CPU scheduler. Therefore, the storage management requires the service provided by the CPU scheduler. And also, the layer rank of a storage management should be higher than the CPU scheduler. So at last, let's see. Then the CPU scheduling will load the process code and the data from main memory. So which means that the CPU scheduler needs the service from the main memory management. And the later rank of a CPU scheduling should be higher than the memory management. So from here, you may already see the problem here. So there is a deadlock among them. Actually, in real world, we cannot map different functionalities into different layers in this layered approach. So although the layered approach is pretty good in ideal case, however, in real world, the layered approach can be applied to part of the functionalities. For the whole entire operating system, it is very hard to do so. And then someone may ask that, so seems like the layered approach is useless. So why we still have layered approach? So even though the layered approach cannot be used in operating system as the only structure, actually it needs to be combined with the other basic structure together to achieve the operating system design goal. However, the layered approach can be perfectly applied on other fields. For example, in computer network system, which is much more complicated than the computer system. So that is why the layered structure has been applied there for people to better understand what happened in each layer. But since it is already beyond this course, so we won't talk about more about that. So later, if you have a chance and want to know more details about computer networks, so we have a course which is a CSCI 361 called Introduction to Computer Networks. So you can learn more from there.